Hi, everyone. I will be talking about the fairness-aware model-agnostic positive and unlabeled learning. I am Ziwei from ICL at University of Illinois at Urbana-Champaign. This is a joint work with Dr. Jingrui. Standard binary classification includes both positive and negative samples. However, in realistic applications, one certain class of data could be difficult to be collected or annotated. For example, in medical diagnosis, while we might safely consider a diagnosed patient to be positive, the much larger population of undiagnosed individuals are practically mixed with both positive and negative examples. Recidivism prediction is also similar. Algorithmic discrimination across demographic groups is observed in existing PUL systems. In breast cancer diagnosis, it has been observed that the accuracy of the diagnosed system is much lower for Black women compared with Caucasian. Racial discrimination is also observed in automatic crime prediction systems. In this project, the problem we want to study is that for any classifier G, we want to minimize its misclassification risk given the constraint that it is fair. We accommodate two different fairness definitions. The first is equalized odds. To be simple, it requires the same true positive rates and false positive rates among different sensitive groups. The second definition is equal opportunity. It only requires the same true positive rate across different sensitive groups. The minimizer G lambda star for every Lagrange multiplier can be derived as below. Here, C is the level frequency, and lambda 1 and lambda 2 is the Lagrange multiplier for constraint of y equals 1 and 0 respectively. In our proposed method, FairPUL, to solve this issue consists of 3 steps. First is to estimate the level frequency using an average estimator, and then we estimate the unfairness. Finally, we search for the optimal lambda using simulated annealing. And we also analyze that our proposed FairPUL satisfies the following asymptotic properties. The first is the asymptotic fairness, and also it enjoys asymptotic optimality. We compare our proposed FairPUL with 2 lines of business, including fairness-aware classification and PUL. And to evaluate the fairness level, we compare AOD and EOD. To evaluate the classification performance, we report the score F1. And from the table, we can see that FairPUL can strike a good trade-off between classification performance and fairness. To conclude, FairPUL first bridges the gap between fair classification and PUL. And under mild assumptions, the model-agnostic FairPUL achieves asymptotic optimal fairness. Last but not least, balance could be struck for better classification performance and higher fairness level in PUL. If you are interested in this work, you can come to my presentation and we can have a more detailed discussion. Thank you.